Hello, and let's discuss how to find the empirical formula for a compound. First off, an empirical formula is the simplest or most reduced ratio of the elements in a compound. For instance, if we had benzene, C6H6, that could be reduced down to CH. So when we're done here, we're basically trying to find a ratio that says each element, but we want to do it in a way that it gives us the smallest ratio. For instance, let's look at the first question. NutraSweet is 57% carbon, 6% hydrogen, 9% nitrogen, and 27% oxygen. We'd like to calculate the empirical formula for NutraSweet. To find an empirical formula, you need to go through the three-step process. So the first thing you want to do is you want to write out your elements. And their percentages. Now what we want to do is we want to have these in grams instead of percents, so we can basically convert them into moles. But that's pretty easy. If you're given a question in percent, let's make the assumption that the total compound is 100 grams, and all you need to do is basically just change all percentage signs to grams. So instead of it being 50% carbon, 57% carbon is going to be 57 grams of carbon. Once you've done that, we want to convert to moles by dividing by the molar mass of each element from the periodic table. So now we have a ratio for each of the elements in terms of moles. However, if you might notice, carbon here says it is 4.758 moles. Although we have the proper ratio, we don't have them as whole numbers. Any formula needs to have a whole number ratio. So what we have to do here is divide each of these by the smallest number, the 0.6795 moles. Any number divided by itself will be 1, so we know, therefore, the smallest number is going to be 1. As for the rest of them, we get 7.002, 8.976, and 2.449. Now, we do want to have a whole number ratio. We can easily round this number to 7 and this number to 9. However, the 2.499 is a problem. It is about halfway in between 2 and 3, and therefore cannot be rounded to either 2 or 3. But since this is a ratio, what we can do is take all the numbers, multiply them by 2 to make it approximately 14, 18, 2, and 5. It would still be the same ratio, but now we have whole numbers, meaning that my empirical formula is going to have 14 carbons, 18 hydrogens, 2 nitrogens, and 5 oxygens. And there's my empirical formula for NutraSweet. Let's do another example. So if the question gives you grams to start off with, then we could just skip ahead and not worry about converting from percentages to grams because we already have it in grams. We can just jump straight into dividing each by the molar mass off the periodic table. Calcium is 40.08, oxygen is 16, and hydrogen is 1.01. So start off by taking the numbers in the question and converting the moles so we get a mole ratio between each of these. Once we've done that, we now have a ratio for moles. However, we need a whole number ratio. So what we need to do is divide by the smallest number. Of these three, the 0.33 is the smallest, so we divide each of them by that number. Meaning this is going to be 1 mole of calcium. This ends up being 2.004 and 1.9842. You can see that this is about 2 and this is also about 2. So we have 1 calcium. So we don't put a subscript there. 2 oxygens and 2 hydrogens. So my empirical formula would be CaO2H2. This is pretty much going to be calcium hydroxide. However, you would give it as this probably a form as the empirical formula, CaO2H2. Let's do one last example. This one's going to be probably the easiest. You'll notice that the question starts off and gives us an empirical formula for a compound made from 0.562 moles of carbon, 1.12 moles of hydrogen, and 0.551 moles of oxygen. Well, we don't need to actually convert to moles since we already have moles. So at this point, all we do is divide each of these by the smallest number. In this case, it's going to be 0.551 to just try to even out our ratio. This number is approximately 1. This number is approximately 2. And of course, anything divided by itself is 1, meaning that my empirical formula is going to have 1 carbon, 2 hydrogens, and 1 oxygen. And again, we don't write ones